A typical nuclear power plant produces approximately 20 metric tons of spent fuel each year. Since the first nuclear power plant came into operation in 1958, the entire industry has produced more than 75,000 metric tons of spent nuclear fuel. If these used fuel assemblies were stacked side by side, it would cover a total volume of approximately 1 football field, 25 feet deep. Of this total volume, 95% of the mass consists of uranium, which can be reprocessed and recycled in order to eliminate the nuclear waste that is currently sitting in large concrete caskets and pools in nuclear power plants across the US. Hello, I'm Brian Minovich with Nuclear Solutions, here to introduce to you a novel method of reprocessing spent nuclear fuel. We have developed a recrystallization process that is safer, more environmentally sound, and more cost-effective than the current liquid-liquid extraction process being used in the nuclear power industry outside of the United States. Our process minimizes employee interactions with equipment, thereby minimizing exposure to the radioactive dissolved fuel rods. By dissolving spent nuclear fuel rods in nitric acid, we were able to utilize a crystallizer to bring solid crystals out of solution and ready to be reprocessed into enriched fuel-grade uranium. After visiting Indian Point Energy Center, a nuclear power facility in New York, it was discovered that over $21 billion has already been committed to the Nuclear Waste Fund for the storage of all nuclear waste since 1958. The current liquid-liquid extraction process can cost a minimum of $500 per kilogram of crystal, but the implementation of Nuclear Solutions process requires an initial investment of $1 million with a cost of only $6 per kilogram of crystal. We have completed our initial design, and Nuclear Solutions is currently seeking additional funding to begin experimental testing. This investment can be seen as a driving force to change US energy policy. And with your support, we can manage nuclear waste more effectively while saving a valuable resource and millions of dollars along the way. Thank you very much for your time.
So this methodology that you're proposing, is this used in other countries, or is it just because the U.S. has a certain restrictions around it that it's not adopted here?
Sure. So the rest of the world uses the liquid-liquid extraction process that I had mentioned previously, but this idea of using recrystallization as the method of extracting uranium would be completely novel to the industry of reprocessing spent nuclear fuel.
Can you talk a little bit, I mean, you talked about the safety for the employees. Can you talk a little bit more about how this would be safer for the surrounding community?
Sure. So nuclear energy usually has a bad stigma when it comes to safety. So one of the main goals, although not initially outlined in our process, but the team decided was that safety would be an important and core value in our design. So we tried to minimize the processing area. So the current liquid-liquid extraction process requires a huge processing area, which is very dangerous in terms of the maintenance that is required. So we tried to use as little moving parts and as little of these very complicated machinery, so there'd be very little maintenance for the employees, as well as a reduction in the size of the processing area that you would need at a nuclear facility.
Excellent. Let's get the voting. Good job. All right. The vote on presentation style. And the vote on business viability. Shot right up. Like that. Nice job.